They thought they had solved the problem. The crew of U-264 believed the metal tube jutting above the waves barely visible, leaving only the faintest wake made them invisible. Captain Lieutenant Hartwig Lux had brought his Type 7IC U-boat to snorkel depth at 0400 hours on the morning of March 27, 1945. Approximately 40 nautical miles west of the Isles of Scilly, the diesel engines rumbled to life, drawing air through the snorkel mast, recharging batteries that had been depleted during 16 hours of submerged running. The crew felt safe. They were 60 feet beneath the surface. No periscope broke the waves. No hull disturbed the water. Only that narrow breathing tube connected them to the world above. Then the alarm sounded, not from their hydrophones detecting approaching propellers, but from the sudden impact of depth charges detonating close enough to throw men against bulkheads. 3 explosions, precisely placed, bracketing the submarine. The lights went out. Emergency lighting flickered on, casting everything in red. Water sprayed from a cracked seam in the pressure hull. Men shouted orders. The diving officer called out the depth as they dropped, fighting to regain control. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Lux couldn't understand it. They had been snorkeling for 20 minutes. Standard procedure. The ocean was rough, with 3-foot swells providing additional concealment. There had been no radar warning. Their Naxos detector had been silent. No aircraft should have found them. Yet a British Liberator from No. 86 Squadron had dropped its depth charges with uncanny accuracy, as if it knew exactly where U-264 was running despite the snorkel being nearly impossible to spot visually in these conditions. The U-boat survived that attack, limping back to Bergen with a cracked pressure hull and traumatized crew. But Lux and his men had experienced something that was becoming increasingly common in the final months of the war, something that shattered the confidence German submariners had placed in their newest technology. Allied aircraft were finding snorkeling U-boats with alarming consistency, detecting them through methods the Germans didn't fully understand. The Snorkel, which was supposed to be the solution to Allied radar and air superiority, had become something else entirely. It had become a liability that made U-boats predictable, vulnerable, and ultimately detectable through a technology most submarine commanders had never heard of. The device that found U-264 was called a magnetic anomaly detector, MAD for short. It didn't rely on visual sighting or radar reflection or sonar pings. It detected the massive steel hull of a submarine by measuring minute distortions in Earth's magnetic field. And it was finding snorkeling U-boats, because those submarines, believing themselves hidden, were running straight and level at consistent depths, making themselves perfect targets for a detection system that required precise flight patterns to work effectively. The confidence that German submariners placed in their snorkels, the belief that this technology had restored their ability to operate safely in Allied-controlled waters, was about to be methodically dismantled by physics, and couldn't hide from and countermeasures they didn't know existed until it was too late. The snorkel wasn't originally a German invention. Dutch naval engineers had developed the device in 1938, fitting it to their O-class submarines as a way to run diesel engines while submerged at periscope depth. The concept was simple: a retractable tube extended above the surface, drawing air down to the engines while a second tube vented exhaust. The submarine could charge its batteries and refresh its air supply without fully surfacing, reducing vulnerability to air attack and surface radar detection. When Germany invaded the Netherlands in May 1940, the Kriegsmarine captured Dutch submarines and examined their snorkel systems with interest. But initially, German Naval Command didn't see the value. In 1940 and 1941, U-boats operated with relative impunity. The happy time, as submariners called it, allowed U-boats to surface freely, run on diesel engines at high speed, and attack Allied convoys without significant air threat. Wolfpack tactics worked. Tonnage sunk was mounting. The Battle of the Atlantic was being won. The snorkel remained a curiosity, a Dutch innovation that solved a problem Germany didn't yet have. That changed in 1943. Allied air power over the Atlantic increased dramatically. long-range B-24 Liberators began patrolling areas previously beyond aircraft range, closing the Atlantic Gap, where U-boats had operated, safely. Escort carriers brought aircraft to convoy routes. Coastal Command flew constant patrols. And critically, Allied radar technology improved to the point where surfaced U-boats could be detected at night and in poor weather conditions that had previously provided concealment. Centimetric radar, operating at wavelengths around 10 centimeters, proved devastatingly effective. U-boats equipped with METOX radar detectors, which listened for earlier meter-wave radar, found themselves surprised by the new systems. Aircraft appeared without warning. U-boats were being caught on the surface, unable to dive quickly enough to escape attack. Losses mounted. In May 1943 alone, Germany lost 41 U-boats. The crew called it Black May. For the first time in the war, U-boat losses exceeded replacement capacity. Gross Admiral Karl Dönitz, commander of the U-boat force, faced a crisis. His submarines could no longer operate safely on the surface. But submerged operation was severely limited. Batteries provided power for only a few hours of underwater movement before requiring recharge. To recharge batteries, U-boats had to surface and run diesel engines, exposing themselves to the very air patrols that were destroying them. The Dutch Snorkel suddenly became relevant. If U-boats could run their diesels while remaining submerged, they could avoid radar detection while maintaining battery charge and operational range. Development and installation began in earnest in late 1943. The German version, called Snorkel, was engineered for retrofitting to existing Type 7 and Type 9 U-boats, as well as inclusion in new construction. The device consisted of two tubes, an air induction mast, and an exhaust mast housed in a single streamlined assembly that could be raised and lowered hydraulically. The head valve, a critical component, featured a float mechanism that automatically closed when waves washed over the snorkel, preventing water, as from flooding into the boat. By spring of 1944, U-boats began returning to Atlantic patrols equipped with snorkels. The initial results seemed promising. U-boats could remain submerged for weeks, surfacing only rarely for navigation fixes or emergency repairs. They avoided radar detection. Aircraft sightings decreased. Submariners felt they had regained the initiative, but German engineering had once again provided a solution to Allied technological advantages. Commanders reported successful patrols. U-264 itself had completed 2 previous patrols, using the snorkel without significant incident. Crews developed procedures and techniques. They learned to snorkel in rough weather when the waves provided additional concealment for the mast. They learned to maintain precise depth control, keeping the boat stable at snorkel depth despite sea conditions. They learned to endure the discomfort, and it was considerable discomfort that came with snorkeling. Inside a snorkeling U-boat, conditions were miserable. When the head valve closed due to wave action, which happened constantly in anything but calm seas, the diesel engines continued running, drawing air from inside the pressure hull. The resulting pressure differential was immediate and painful. Eardrums popped, sinuses ached. Men felt crushing pressure in their chests. When the valve reopened and air rushed back in, the pressure equalized violently, sometimes causing nosebleeds and severe headaches. The diesel exhaust system, despite engineering efforts, leaked. Carbon monoxide seeped into the crew compartments. Men developed headaches, nausea, and confusion. Some lost consciousness. Every snorkeling patrol meant enduring these conditions for hours at a time, sometimes for days on end when tactical situations prevented surfacing. But submariners accepted this. They believed the alternative, surfacing into Allied air patrols, was worse. The snorkel, despite its discomforts, seemed to offer survival. German propaganda reinforced this belief. Reports emphasized U-boats successfully evading Allied patrols. Technical journals discussed the snorkel as a superior solution to Allied radar. Training emphasized snorkeling as the primary operating mode for all future patrols. The magnetic anomaly detector was not a radar. It didn't send out signals and wait for reflections. It was a passive sensor, measuring something submarines couldn't hide: the distortion their steel hulls caused in Earth's magnetic field. The principle was straightforward. Earth generates a magnetic field, invisible but measurable, that varies slightly depending on location and local geological conditions. A large ferrous object, like a submarine hull containing hundreds of tons of steel, creates a localized distortion in this field, an anomaly that sensitive instruments can detect. Development of practical MAD equipment began in the United States in 1941 at the Gulf Research and Development Company laboratories in Pittsburgh. Physicists and engineers worked to create a detector sensitive enough to identify submarine-sized magnetic anomalies, while being robust enough for military use aboard aircraft bouncing through turbulent air. The challenge was substantial. The magnetic signature of a submerged submarine was minute compared to Earth's background magnetic field. Detecting it required instruments capable of measuring variations as small as 1 part in 50,000 of the total field strength. By 1942, working prototypes existed. The AN/ASQ-1 MAD detector consisted of a magnetometer housed in a streamlined tail assembly, called a MAD boom or bird, extending behind the aircraft. This placement, far from the aircraft's own steel structure and engines, minimized interference. The magnetometer used a saturable core induction coil design, essentially a coil of wire wrapped around a magnetically sensitive core. Changes in the magnetic field induced tight electrical currents in the coil, which were amplified and displayed to the operator. The effective detection range was limited by physics. MAD could detect a submerged submarine at approximately 400 yards laterally and up to 150 feet in depth. These weren't long ranges. Unlike radar, which could detect surfaced vessels at several miles, MAD required the aircraft to pass almost directly over the submarine. This necessitated precise search patterns and careful navigation. Aircraft equipped with MAD flew systematic parallel tracks called mowing the lawn, covering areas where submarines were suspected or reported. The U.S. Navy began operational deployment in 1943, initially aboard PBY Catalina flying boats, and later on PV-1 Ventura patrol bombers operating from escort carriers. The British received MAD equipment through Lend-Lease, installing it primarily on Consolidated Liberator maritime patrol aircraft. By 1944, hundreds of Allied patrol aircraft carried MAD detectors, particularly those assigned to anti-submarine warfare in critical areas, the Bay of Biscay, the English Channel approaches, the waters around Gibraltar, and the convoy route south of Iceland. Operators required training to interpret the equipment. The MAD detector produced a continuous trace on a paper chart recorder, drawing a baseline showing normal magnetic field strength. When the aircraft passed near a submarine, the trace spiked sharply upward or downward depending on the submarine's magnetic orientation. The operator watched this trace constantly during patrol flights, calling out contacts to the pilot and bombardier. False contacts were common. Shipwrecks on the ocean floor, geological formations, even schools of certain fish could produce small anomalies. But the signature of a submarine was distinctive, a sharp, symmetrical spike that rose and fell quickly as the aircraft passed overhead. The real power of MAD wasn't in long-range detection. It was in providing precise localization for weapons delivery. Once radar or visual observation identified a general area where a submarine might be operating, MAD allowed aircraft to pinpoint the exact location for depth charge or acoustic torpedo drops. And critically, MAD worked against snorkeling submarines that had no hull breaking the surface, no large radar signature, and minimal visual profile. The snorkel mast itself was nearly undetectable by radar, and almost impossible to spot visually except in calm seas. But the submarine's steel hull 60 feet beneath that snorkel created the same magnetic anomaly whether snorkeling or fully submerged. The pattern emerged slowly through operational analysis conducted at the Admiralty's Submarine Tracking Room in Liverpool and at U.S. Navy headquarters in Washington. U-boats equipped with snorkels were being attacked at higher rates than expected. More significantly, they were being attacked while snorkeling in conditions where visual or radar detection should have been nearly impossible at night. In rough weather, With only the snorkel mast exposed, Lieutenant Commander Peter Gretton, an experienced escort commander who had transitioned to analytical work at Western Approaches Command, noticed the correlation in February 1945 while reviewing loss reports. Aircraft equipped with MAD were achieving attacks on snorkeling U-boats at rates substantially higher than visual or radar contacts would predict. In one 10-day period, 7 separate MAD-equipped aircraft reported successful attacks on submerged contacts in the Western Approaches. 4 of those attacks resulted in confirmed U-boat kills, 3 more damaged submarines that limped back to French or Norwegian ports. The tactical situation that made MAD so effective against snorkeling U-boats was predictability. A U-boat running on the surface could maneuver freely, changing course and speed unpredictably. A fully submerged U-boat running on batteries moved slowly and often crept along near the bottom, making it difficult for aircraft to maintain contact. But a snorkeling U-boat operated under specific constraints that made it an ideal MAD target. To snorkel effectively, a U-boat maintained a precise depth, typically between 50 and 70 feet, keeping the snorkel head just above the surface. The submarine needed to run straight and level, because any significant maneuvering risked the snorkel breaking the surface too far, making it visible or dipping too deep, and allowing waves to flood the head valve continuously. Speed had to be moderate, usually 6 to 8 knots, fast enough to make progress, but slow enough to maintain depth control and prevent excessive snorkel wake. These operational requirements meant snorkeling U-boats moved in predictable patterns. Once detected by any means, a coastal radar station spotting a snorkel mast, a direction-finding station triangulating radio transmissions, or simple probability based on known transit routes, aircraft could search likely areas with MAD, flying systematic patterns at low altitude. When the MAD trace spiked, the bombardier released weapons immediately. The U-boat, constrained by snorkeling depth and limited ability to maneuver quickly, often remained within the weapon's lethal radius. U-995 experienced this on April 8, 1945, northwest of the Hebrides. The boat had been snorkeling for 3 hours, transiting toward patrol areas off the North Channel. Weather was overcast with moderate seas, conditions the crew believed provided concealment. A British Liberator from No. 120 Squadron, equipped with MAD and patrolling the area based on Admiralty intelligence estimates of U-boat movements, picked up the magnetic signature at 09:15 hours. The aircraft's MAD operator, Flight Sergeant Thomas Hawkins, saw the trace spike sharply. He called the contact immediately. The pilot, Flight Lieutenant James Morrison, banked the aircraft into a tight turn, bringing it back over the contact location. The bombardier armed 6 depth charges, set to detonate at 75 feet. On the second pass, the MAD trace spiked again, confirming the submarine's position and heading. Morrison held the aircraft steady. The bombardier released the depth charges in a perfect straddle pattern. U-995's crew heard the aircraft pass overhead twice. They had no idea they'd been detected. Their Naxos radar detector remained silent because MAD emitted no signals to detect. The commander, Oberleutnant Zur C. Walter Kerntop, assumed the aircraft was on routine patrol, unaware of their presence. Then the depth charges detonated. All 6 exploded within 100 feet of the pressure hull. The impact was catastrophic. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The after battery compartment flooded immediately. Control surfaces jammed. The boat went into an uncontrolled dive, passing 200 feet, then 300. Men screamed. The pressure hull groaned under forces it was never designed to withstand. At 360 feet, the hull collapsed. U-995 imploded, killing all 52 men aboard in less than a second. The Liberator crew saw the oil slick and debris field appear on the surface minutes later, confirming the kill. German naval intelligence knew Allied aircraft possessed some kind of improved detection capability by late 1944. but they struggled to understand how it worked. Interrogations of captured Allied aircrew occasionally mentioned magnetic detection equipment, but these reports were fragmentary and often dismissed as disinformation. The concept seemed implausible to German engineers who understood the theoretical difficulties of detecting magnetic anomalies from aircraft. Kapitän zur See, Gunther Hessler, Dönitz's son-in-law and a senior staff officer in the U-boat command, compiled reports of suspicious attacks throughout the winter of 1944 and 1945. He noted that U-boats were being attacked while snorkeling under conditions where conventional detection methods should have been ineffective. He theorized that Allies might have developed extremely sensitive radar capable of detecting the small snorkel mast, or possibly infrared detection systems that could identify the warm exhaust gases from diesel engines. The truth was simpler and more inescapable than German planners realized. MAD detected the one thing submarines couldn't hide: their steel hulls. No amount of tactical adaptation could eliminate a submarine's magnetic signature. Unlike radar signatures that could be reduced through design and materials, or acoustic signatures that could be quieted through engineering, the magnetic anomaly was fundamental to the submarine's construction. Hundreds of tons of steel in a long, cylindrical shape created a predictable, detectable distortion in Earth's magnetic field. For U-boat crews, learning about MAD through the rumors and fragmented reports that filtered through the submarine service, the realization was deeply unsettling. The Snorkel, which they had believed made them nearly undetectable, had instead made them more vulnerable by forcing them into predictable operating patterns. They ran straight and level at consistent depths, perfect targets for a detection system that required aircraft to fly precise search patterns. Franz Kurowski, a warrant machinist aboard U-777, recorded his thoughts in a journal later recovered from the wreckage when his boat was sunk in May 1945. His entry from April 23 described the crew's growing awareness that something was wrong. "We snorkel and believe ourselves safe. The commander says the snorkel makes us invisible to enemy radar. Boats are not returning. U-231 gone while snorkeling. U-486 gone while snorkeling. The English find us somehow. We don't understand how, but they find us." The psychological impact extended beyond individual crews to the institutional level of the Kriegsmarine. The Snorkel program had consumed enormous resources: engineering development, manufacturing capacity, installation time in shipyards, and crew training. It represented the Navy's primary technical solution to Allied air superiority. If the Snorkel didn't provide the protection it promised, if Allied aircraft could find snorkeling U-boats as easily as surfaced ones, then the entire operational concept of late-war U-boat warfare was flawed. Dönitz, in his capacity as Commander-in-Chief of the German Navy following Gross Admiral Erich Raeder's resignation in January 1943, faced an impossible situation. He couldn't withdraw the U-boats from operational areas because Hitler demanded they continue attacking Allied shipping to disrupt the supply lines supporting the invasion of Europe. He couldn't order boats to surface and run on diesel engines, because Allied air patrols would destroy them even faster than they were being destroyed while snorkeling. The Snorkel remained the least bad option, even as evidence mounted that it provided less protection than originally believed. The Snorkel paradox that the technology meant to protect U-boats had instead made them more vulnerable to a detection method they didn't fully understand, defined the final months of the U-boat war. From January through May 1945, German submarines continued operations under increasingly desperate circumstances. Boats departed Norwegian bases, knowing their chances of survival were minimal. Crews understood the mathematics. More U-boats were being sunk than were sinking Allied ships. In April 1945 alone, 55 U-boats were lost. Many were destroyed while snorkeling, caught by MAD-equipped aircraft that found them in waters where visual or radar detection should have been nearly impossible. The Bay of Biscay, once a transit route for U-boats moving between French bases and Atlantic patrol areas, became a killing ground. Allied aircraft, flying systematic search patterns with MAD detectors, found snorkeling U-boats with regularity that German commanders couldn't explain. U-236 departed Bergen on April 14, 1945, under command of Oberleutnant Erich Klausberg. The boat carried a full load of torpedoes and provisions for an 8-week patrol. Clausberg had orders to operate against Allied shipping lanes west of Ireland, interdicting convoys supplying the final push into Germany. The boat never reached its patrol area. On April 19th, a Royal Canadian Air Force Liberator from No. 10 Squadron detected U-236 while it was snorkeling northwest of the Shetland Islands. The MAD contact was clear and unmistakable. The aircraft dropped depth charges. U-236 went down with all hands. U-320 departed Kristiansand on April 21st under command of Kapitän Lieutenant Heinrich Niemeyer, an experienced commander with 3 previous patrols. The boat's orders directed it to patrol areas in the North Channel, targeting shipping between Scotland and Northern Ireland. On April 24th, while snorkeling in moderate seas 30 miles west of the Mull of Kintyre, U-320 was detected by a British Liberator using MAD. The aircraft made 3 passes, confirming the contact each time. Depth charges destroyed the boat. 49 men died. The pattern repeated across operational areas: U-boats snorkeling in the Irish Sea, the western approaches, the waters around the Faroe Islands, and the Norwegian Sea were being found and destroyed. The operational calculus that had once favored submarines, the vast ocean providing concealment. The difficulty of finding a small vessel in enormous search areas had shifted decisively against them. MAD didn't need to search vast areas effectively. It only needed to search areas where submarines were likely to be, where intelligence suggested they might operate, where probability and operational necessity forced them to transit. German submariners adapted as best they could with the information available to them. Some commanders began snorkeling only during daytime hours, reasoning that aircraft operations were slightly reduced at night, though this adaptation provided minimal benefits since MAD worked regardless of light conditions. Others snorkeled only in the worst weather, believing storms would keep aircraft grounded, which was partially effective but also made snorkeling itself more dangerous, as violent seas could damage the snorkel mast or flood the boat through the head valve. Some crews requested assignment to the newer Type XXI electroboats, submarines with massive battery capacity that could operate submerged for extended periods without snorkeling. These boats, designed specifically to counter Allied air superiority, featured streamlined hulls for high underwater speed and enough battery power to run submerged for 2 to 3 days at patrol speeds, but only 2 Type XXI boats completed operational patrols before the war ended. German shipyards, devastated by Allied bombing and starved of raw materials by collapsing supply lines, couldn't produce them in meaningful numbers. The U-boat crews who survived until Germany's surrender on May 8, 1945, emerged from a campaign that had consumed the Kriegsmarine's submarine force almost entirely. Of the roughly 1,150 U-boats commissioned during the war, 785 were lost. 30,000 men served in U-boats. 28,000 died, a loss rate of 75%, the highest of any military service in any nation during World War II. The Rhine's surrender of the U-boat fleet in May 1945 provided Allied intelligence with unprecedented access to German submarines, equipment, and documentation. Technical intelligence teams examined captured boats, interviewed survivors, and analyzed operational records. What they discovered confirmed what operational data had already suggested. German submariners had been operating with incomplete understanding of Allied detection capabilities throughout the final 18 months of the war. Commander Kenneth Knowles, head of the Atlantic section of the U.S. Navy's Operational Intelligence Center, reviewed German U-boat logs recovered from surrendered vessels and captured bases. The logs revealed that U-boat commanders attributed their losses primarily to improved Allied radar and increased air patrols. Few mentioned magnetic detection. Most had never heard of MAD, the technology that had contributed substantially to U-boat losses in the war's final year, remained largely unknown to the men it was killing. This intelligence asymmetry, Allied knowledge of German capabilities, combined with German ignorance of Allied capabilities, had proven decisive. German engineers had developed the Snorkel as a countermeasure to radar detection, and the Snorkel worked as designed. It reduced radar signature dramatically, But Allied forces had already moved beyond radar as their primary anti-submarine detection method. In scenarios where U-boats used snorkels, MAD provided the capability to find submarines that were otherwise nearly invisible, exploiting the very operational patterns that snorkeling required. British and American technical experts who examined captured Type 7 IC boats with snorkels installed noted the engineering quality of the equipment. The snorkel masts were well designed, with effective head valves and reliable hydraulic raising mechanisms. The integration into existing boats was competent. The equipment worked as intended, but it solved the wrong problem. Or rather, it solved the right problem: radar detection, while inadvertently creating vulnerability to a different threat that German planners hadn't anticipated, because they didn't know MAD existed in operational form. Post-war analysis conducted by the British Admiralty's Anti-Submarine Warfare Division calculated that MAD-equipped aircraft achieved successful attacks on snorkeling U-boats at roughly 3 times the rate of aircraft without MAD operating in similar areas during the same period. The technology wasn't a silver bullet. Most U-boat kills still came from convoy escorts using sonar, or from aircraft using radar to catch U-boats on the surface. But in the specific tactical scenario of hunting snorkeling U-boats, MAD provided a significant advantage that German forces had no effective counter for. The human cost of this technological asymmetry was measured in U-boat crew rosters and loss reports. U-953, U-881, U-232, U-777, U-320, U-236, and dozens more. Each entry in the loss ledger represented 50 men, most in their early 20s, who died believing their snorkels provided protection that, against MAD-equipped aircraft, they did not provide. They snorkeled according to doctrine, maintained proper depth, followed procedures, and died when depth charges found them anyway. Survivors struggled with the revelation. Korvettenkapitän Peter Kramer, who commanded U-333 and survived the war, wrote in his memoir about learning that Allied aircraft had been detecting U-boats through magnetic signatures. His reaction mixed disbelief with anger: disbelief that such technology existed and could work effectively, anger that German intelligence had failed to identify this threat and develop countermeasures. He described conversations with other surviving commanders who expressed similar feelings, a sense that they had been fighting blind, unaware of the capabilities arrayed against them. The snorkel itself continued service in post-war navies. The concept was sound. Submarines could benefit from running diesel engines while submerged. Every modern diesel-electric submarine built after 1945 incorporated snorkel technology in some form. But the tactical situation changed. Post-war submarine doctrine emphasized deeper operations, faster submerged speeds, and better understanding of detection threats. The predictable straight-line snorkeling at fixed depth that characterized German operations in 1944 and 1945 became recognized as tactically dangerous. MAD technology also continued development. The US Navy improved detector sensitivity and installed MAD equipment on helicopter anti-submarine platforms, where the ability to hover over a suspected contact made MAD's short detection range less limiting. Soviet submarines faced MAD-equipped aircraft throughout the Cold War. Modern maritime patrol aircraft still carry MAD detectors, though their importance has diminished relative to other sensor systems like sonar buoys and infrared detection. The story of German U-boats, snorkels, and MAD detection illustrates a fundamental truth about technological warfare: that solutions create new problems, that advantages exist only relative to adversary capabilities, and that the gap between what forces believe about their equipment and what that equipment can actually accomplish often determines survival. German submariners believed the snorkel made them invisible. They were wrong. Allied forces had developed a detection method that didn't care about radar signatures or visual profiles. It detected the inescapable physics of hundreds of tons of steel displacing Earth's magnetic field. This wasn't a failure of German engineering. The snorkel worked. It accomplished its design purpose of allowing submerged diesel operation. The failure was strategic and institutional. The failure to understand that adversaries would adapt, that technological advantages were temporary, that the enemy was developing capabilities in laboratories and testing ranges that would only become apparent when they began destroying U-boats at sea. By the time German submariners realized Allied aircraft were finding them through methods their equipment couldn't detect or counter, it was too late to develop responses. The war was ending. The U-boat force was being destroyed faster than it could be replaced. Kapitänleutnant Hartwig Lux, whose U-264 survived the attack described at the beginning of this account, surrendered his boat in Bergen on May 9, 1945, the day after Germany's capitulation. His crew, shaken by their experiences, learned during surrender processing that Allied aircraft had been using magnetic detection equipment. Lux later told British interrogators that knowing this information earlier wouldn't have changed tactics significantly. U-boats still needed a snorkel to charge batteries, and there was no practical way to shield a submarine's magnetic signature while maintaining operational capability. But the knowledge would have changed expectations. Crews would have understood that snorkeling offered concealment, not invisibility, that risk remained despite following procedures, that survival depended as much on luck as on proper operation. The broader lesson extends beyond U-boats and MAD to the nature of technological competition in warfare. The side that understands both its own capabilities and its adversary's capabilities holds an enormous advantage. The side operating with incomplete information, believing its countermeasures are effective when they're being systematically defeated by unknown methods, faces not just material disadvantage but psychological disadvantage. Confidence built on false assumptions collapses when confronted with reality, leaving forces demoralized and tactically confused. For the 28,000 men who died in U-boats during World War II, many in the final months while snorkeling under the belief that they were protected, the lesson came too late or not at all. They climbed into their boats, submerged to snorkeling depth, ran their diesels, recharged their batteries, and continued their patrols. Some completed their missions and returned to base. Most did not. They remain in their steel coffins on the ocean floor, casualties of a technological race they didn't know they were losing until the depth charges came down, and the pressure hulls collapsed and the Atlantic took them. The morning of March 27, 1945, U-264's crew believed their snorkel made them invisible. By the time the depth charges exploded around them, they knew differently. They were among the fortunate ones. They survived to learn the truth. Thousands of their comrades did not. They died believing the snorkel protected them, never knowing that Allied aircraft above them were following traces on paper charts, watching magnetic anomaly detectors spike as they passed over submarines that thought they were hidden but were, in fact, as visible as if they had been running on the surface in broad daylight. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.